This video will help you with solving radical equations, especially if we have extra variables or rational exponents. So first, when we look at this problem, I might notice that I've got an x on the left side and the right side. So we can still solve this using the same strategies. It's just going to have some extra steps with algebra. So remember, the first thing we always want to do is isolate the radical sign. So I notice my radical, I see I have plus 3, so I'm going to subtract 3 from each side so that my radical is isolated. Okay, now that I just have a radical on the left side, I'm going to get rid of that by doing the opposite operation. So if it's a square root, I can square each side. So on the left side, it's still kind of that canceling situation, and we just end up with 5x minus 1. But on the right side, this is a little different from what we were seeing because we have x minus 3 squared. So be really careful because that means we have 2x minus 3's. That squared is telling us it's x minus 3 times x minus 3. So we need to do some foiling here to help us see what we get. So x times x squared, x times negative 3 is negative 3x. And then we get another minus 3x, and then negative 3 times negative 3 is positive 9. So we see we've got two like terms in the middle we can combine. So this right side becomes x squared minus 6x plus 9. So again, that 6x is from my like terms in the middle. So you have to be so careful to FOIL there. If you just did x squared minus 3 squared, no bueno, that's not good. That is going to lead you to a wrong solution. Okay, now that we've gotten rid of the radical sign, we can proceed with solving it. And since I notice an x squared on the right side, I'm going to keep that positive, so I'm going to move this stuff from the left side to the right side. At this point, a good step is to set equal to 0. So I'm left with 0 on the left side, and then I have x squared minus 11x plus 10. Well, from here, all we have is a factoring problem. So we factor to find our solutions because we're just trying to solve for x. So since we've got a trinomial, we can do the M method and multiply the first and last terms. And it looks like we're looking for magic numbers that multiply to positive 10 and add to negative 11. So I'm going to try negative 10 and negative 1. And then I bring down the last term and the first term. Now that I've got 4 terms, I use my grouping method. So I can factor an x out of the first group, and in the second group, I'm just going to factor out a negative 1. And I see that these two groups are the same, which is good. So rewriting, I have the x minus 10 group, and then this x and this minus 1 make my other group. Whew, so this was definitely a longer problem to solve, but now we are at the end. To get what x equals, we just need to set each piece equal to 0. So I end up with x equals 10 or x equals 1. So that was all the hard work of solving it, but because we had a radical, we always need to check our answers. So always plug it in when we've got radicals in our equations. So since we have 2 potential answers, we need to plug in each of them separately. So I'm just going to copy down my original problem. So first I'll plug in 10. I'm going to leave myself some space, and I'm going to do the exact same thing. I like to write them each to start so I don't forget that I need to plug in both of them. So I've plugged in 10, I've plugged in 1, now I just need to simplify that. So under my radical, I get 50 minus 1. So I get 49. I can subtract that 3 over, so I get 7 and 49. The square root of 49 is 7. 7 equals 7. So that means x equals 10 is a solution. And then I simplify the other one, so I get 5 minus 1 plus 3 equals 1. Square root of 4, if I subtract the 3, I'm going to get negative 2. The square root of 4 is 2 equals negative 2. That is not equal, so x equals 1 is an extraneous solution. It does not satisfy our equation. All right, great job.